call is now being recorded.
Shall I start?
Hello everyone. Good morning to all. Good afternoon to all. I am Jidin Chandrababu Tumbekalam, Assistant Professor of Civil Engineering, FXCC Tirunelveli. On behalf of FXCC, I would like to extend a very warm welcome to every one of you who is listening this session. We thank you all for taking out of your schedule and joining us with this. People who feels good about themselves do great work and create great things. One such person is here with. I am so glad in introducing our honorable speaker, Dr. Girish Gopinath. He is a knowledgeable person and become a most distinguished and successful professor. He is presently working as Associate Professor, Department of Remote Sensing and GIS, Cochin, Kerala. He completed his BSc degree in geology from MG University, Kottayam in 1994 and completed MSc in geology with first rank in 1996 from Mahatma Gandhi University, Kottayam. He obtained his MTech in remote sensing with first rank in 1998 from Bharatidasan University, Tiruchirappalli, Tamil Nadu. And he completed his PhD from Cochin University of Science and Technology in 2004. His area of interest are natural resources management, hydrogeology, and geomatics. And 20 plus articles in both national and international journals. He has published or edited 7 books, and he has memberships in more than 10 professional bodies. Dr. Girish Gopinath, sir, for this session on data available from remote sensing. I hand over this session to him. Over to you, sir. Thank you.
Thank you. Thank you, Jidin. Shall I share my system?
Okay, sir. Okay.
Okay. Can you able to see my PPTs, Jidin?
No, sir. Just 1 second, sir.
It's not coming?
No, not visible, sir. Your face is visible.
Now it is coming.
No. Yeah. Yes, sir. Yes, sir.
It's coming.
Yeah.
I'll put.
Okay, sir.
Yeah, now it's clear.
Yes, sir. It's visible.
Yeah. Good afternoon to all. Okay, if any problem is there, Jidin, just tell me in between. Because in Google Meet there is always an issue, so you have to remind me because my phone number is already with your Professor Kannan. If anything happen in between, you can just ring me up or just send me a WhatsApp message like that.
Okay, sir.
Okay. So we will begin with our lecture. So I will break up in between some 10 or 15 slides. Then we have a discussion. Then we'll go for further like that. Maybe I am planning like that. We don't know how we do like that. We'll see like that. So before going to my chapters, I will go to some introduction about what are the current trends in remote sensing and geospatial technology, because people are already talking about geoinformatics, bioinformatics, hydroinformatics, like that. So there's a lot of terminology we are using in remote sensing GIS. The geospatial technology is nothing but it refers to all of the technology used to acquire, manipulate, and store Geographic Information System. So GIS is one of the geographical technology like that GPS, Global Positioning System, remote sensing, like that are other example for geospatial technology. So geoinformatics is nothing but it is a combination of geospatial information technology and mathematical. Geomatics is nothing but it includes most of the mathematics of the earth like that. And nowadays people are familiar with the WhatsApp, Facebook like that, and also people are taking a lot of photographs in the field like that. So there is a word called geotagging. Nowadays, all the cameras and videos are having a geotag. You can take a geotag photos and you can put in your Google Earth also. So there's a lot of options for geotag photos like that. Why I am emphasizing on geotagging means, suppose you are doing for a flood mapping or a landslide like that, you are doing a lot of sampling in more than a per season, you are taking 100 samples per day. So you will feel it is very difficult to remember the location like that. So you can put in a geotag format and you can put in the Google Earth, and once you are again going to the field, your GPS or a Google Earth also will help you to find out the exact location. So geotagging having a lot of application nowadays. Another is geofencing. Geofencing is nothing but you are fencing your geographic location. Suppose you are in the Facebook. Nobody want to see within the 30 kilometer like that. You can do a geofencing. Now in the it's a time of COVID. We are sitting in the home or a work like that. The government is doing a lot of application of GIS to track to COVID people, how many COVID people in a particular taluk or a district. So which cluster like that having a more this one. So geospatial technology having a lot of application nowadays. Even there's a branch of GIS is called health GIS. Now most of the foreign countries they have started health GIS, vector analysis like that. So there's a lot of advance in the technology. So we have to pop up with the technology like that. What are the coming? This one. So this is a three, you can see the three circles. These three circles are the component of geoinformatics. So geoinformatics is nothing but it is a combination of remote sensing, GIS, GPS. So simple remote sensing, I know there is already a class by Professor Kumarasamy sir. He explained all about remote sensing, basic funda like that. So remote sensing is nothing but if you take a photograph from your mobile, that's a remote sensing. A simple definition. I am not going to definition like that, but there is a lot of advancement in that field of remote sensing. When you see on the top, I have written aerial, satellite, thermal, radar, LiDAR, hyperspectral, and UAVs. So when you look at on the right side of a circle, you can see there's a number of small circles are there. So all this together will take a remote sensing. Remote sensing is nothing but you are getting a data from a platform. A platform may be a satellite, platform may be an aircraft. Sometimes the technology will change based on the EMR, electromagnetic radiation, like that. Here what I mentioned is aerial means the aerial remote sensing. So your camera or a sensor should be in the aircraft. So we are calling as the aerial remote sensing. Suppose it is in the satellite, you are calling as a satellite remote sensing. So thermal, there's another branch of remote sensing based on the electromagnetic radiation. I will explain later. Then we are calling as a radar. You heard about radar, sonar like that. Then there is a LiDAR. Then hyperspectral and UAV. I will explain later on data, what type of data this one on later slides. That's the one part remote sensing. When you see on the left side, you can see GIS. GIS having a tremendous growth. You maybe heard about lots like RGIS, QGIS, like that. There's a map info. There's a lot of software is available. And GIS is also classified as internet GIS, web GIS, like that. It's another part, and the bottom part you are getting a GPS. That's a global positioning system. The GPS having a two application is there. The one is to find out your location. Suppose you are standing in somewhere in Thuthukudi or Tirunelveli, you know what is your x and y. Usually you are talking about x and y as a Cartesian coordinate. Here we are talking about the latitude and longitude. The second application is for navigation. Suppose you are in the ocean. You want to find out your northing and easting. So GPS will help you to find out your northing and easting. So you are getting a data. Everything, the paper, information written in paper is a data, right? It's a piece of paper, what you have written, your height, what is the height of a person, what is its location, that's a geographical data. So when you put a data in, also it is a data. The Excel, what you are getting in Excel is data. So data means wherever you are getting is a piece of information, is a data. All the data you are putting in GIS format. That means you having an X and Y control. X and Y here we are talking about your latitude and longitude. When we discuss anything about X, Y is in the lecture, that means X, Y is your latitude and longitude, and that is your altitude. Altitude means a height in motion like that. So GIS is nothing but it will capture all data to manipulate. You can do an analysis, you can get an information, all the things. But data you have to convert in the form of a knowledge. So remember these three fields. One is a GIS, remote sensing, and GPS. If you are not clear, you can ask the question in between. There is not an issue with that. So when you my lecture will be about the outline will be, so I will not discuss about all the data. Data means it is a very huge, there is a lot of satellites, more than 1,000 satellites are in orbit, but about 1,400 satellites are working satellites. So the data, huge data sets. So I will, all the remote sensing data, I will take only a selected RS data, remote sensing data. And also I will about how you can use this data for a particular application like that. Then I will discuss about, based on the time, discuss on how the data is available. That's a free data and open source software. Because when we are doing a masters in the olden days, we are worried about the data and also software. But nowadays, if we just type in Google free GIS software, you will get more than 1,000 pages. And the same thing, you can just type free satellite, you can download a lot of data from the internet. So now data and software is not an issue for doing any sort of work. So the outline is like that. So before I starting with the data, that's the first slide on this one. So I will just already, this one is discussed by the first speaker, because why again I mentioned everything having a clear picture of that's electromagnetic radiation. Then only the thing is that in which data, where you have to use, that is a depending upon you cannot use all the data in all the data for a particular application. That the data depending upon a lot of things. That is about wavelength of the data, then what type of platform you are getting, what's the resolution of data, whether it is temporarily available like that. So that will be discussed. We'll go for the data like that. The first thing you have to keep it in mind when you take an electromagnetic radiation up to UV, ultraviolet cannot be used for the satellite remote sensing because all the energy is get absorbed by atmosphere. So you can take from the visible part of the spectrum, that's a 0.400 micrometer to from a radio waves. So basically here remote sensing is classified on optical, thermal, microwave like that based on the electromagnetic radiation. So each spectrum having its own application. Even if I am talking about thermal Thermal is operating between 8 to 15 million. It is having some atmospheric windows. I'm not talking all the basic things, but the things you have to keep it in mind that the selection of data of a user is again depending upon your type of project. You cannot select all the data for a particular project. I will discuss later in the later slide why it is coming like that. So you have to keep it in mind, electromagnetic radiation and what is the wavelength, what is the energy. In the basic equation also you have to keep in mind Q is equal to hc by lambda. When you go for a higher wavelength, the quantum of energy is very less. So when you go for a microwave part of the spectrum, there is a lot of noises out there. So what we are talking about signal noise ratio. It is very difficult to differentiate a signal and noise if you go for a higher wavelength. So basic of that one of electromagnetic radiation. So remote sensing data, just I classified remote sensing data. You can classify it is my own classification based on the source of energy. It is whether it is an active sensing or passive. Suppose you are taking the energy source of sun, you are passive remote sensing. Active means you are sending a signal, you are getting back a signal that you are calling as a active data like that. And based on the platform, you can classify data to a aerial remote sensing, satellite remote, or terrestrial also. If you are taking from the lands, that is also remote sensing. You have terrestrial sensing. Another is it is calling as a aerial remote sensing. So based on the electromagnetic radiation, you can classify into the thermal remote, optical remote sensing, thermal remote sensing, and microwave like that. So these are the classification like that. And if you go for another level of remote sensing, we have data in a panchromatic mode. That means it is a black and white. Then you having a multispectral, you having a different bands, band 1, 2, 3, 4 like that. What we are talking about band 1, 2, 3, 4 is a blue, green, red, or infrared. Sometimes blue is not there. Blue having more scattering. So later IRS 1A and 1B, they removed blue bands because of the Rayleigh scattering. They had taken green, red, infrared, and shortwave infrared, SWIR. Each band having its own application. So there is a new branch of remote sensing called hyperspectral remote sensing. So instead of using a discontinuous band, you are using a continuous spectral that you are calling as a hyperspectral remote sensing data. And there's a new branch of remote sensing is coming as is ultraspectral. If you are using a more than 1,000 bands, it is calling as an ultraspectral. That's the basics of data. So you have to keep in one more thing is that again, if you go for a project, you have to select what type of data, what type of platform, what type of energy like that. So this slide regarding the basics, then we will go to the data. So resolution is also very important. There are 4 types of resolution already explained: the spectral, spatial, metric, and temporal. Temporal is nothing but if you want to study a long-term changes of a land use. Suppose if you want to take a Tamil Nadu or Kerala or anywhere in India, you want to study a long in the land use pattern or anything, water body changes, you need a temporal data. That means depending upon time. If you want to study a decadal change, you having a data of 2010, and you need a 2020 like that. Let's see what are the changes. The radiometric is nothing but your how much gray levels you are using. Suppose usually our Indian satellite are 2�9 and 2⁸ data. That means you having a 256 gray levels starting from black to white. And if you take an icons or a high resolution data, it is 4:11 data. It is having a 1044 discrete levels are there. Suppose if you are increasing the level, you are getting a more information about the terrain. The spatial is nothing but it's a simple definition of spatial resolution is the size of a pixel. Suppose if you take a satellite data, you just zoom it, or your photo also if you take, when you zoom it, you can see it's in the pixel. Pixel is nothing but it is having a both x and y values. So it is x and y is having an equal length dimension. Suppose it is a 30 centimeter or 30 meter, so the resolution of data is a 30 meter. So resolution is very important for any type of project. If you're talking about data, the data should be having a, suppose if you're taking a data on 1973, your data is having a resolution of 120 meters. Suppose now we are getting a resolution of 35 centimeter down, where we do like that. So nowadays there's a multi-temporal, multi-spatial, multi-spectral, multi-radiometric data are available, and there's a lot of techniques are there. We can make it to a common platform. So spectral is nothing but how many bands are you are using. Now hyperspectral is come up. In when you come to panchromatic and multispectral having a more spectral resolution than case of panchromatic. And again, a simple comparison between Indian satellite and Landsat. Indian satellite having some 4 bands for IR series, but if you take a Landsat, it is a 7 to 11 bands. So if you're having a more bands, you will get a more information about the terrain. So if you want to discuss anything on Jitin? Hello?
Participants, if you have any queries regarding the section, you can raise now.
You can raise now, it is easy unless they will sleep, that is why.
Continue, sir. No problem.
No, if you because these are the basic things what I say. If you have any clarification, they can ask. It is not whether they can ask any question. It is not an issue like that.
Okay. But dear participants, if you have any queries regarding this upcoming session, last section,
ask your queries because it should be lively. Unless I will speak once, I will be just like a GPS, right? GPS, you know what is a GPS? GPS is actually just like a radio. It will get us like that. Radio will speak, but we cannot. Others can hear only. So it will not happen. That is why you have 1 or 2 questions, basics or anything.
Participants, if you have any queries regarding the basics, you can raise now.
Unless I will ask you questions to participants. Shall I ask you some questions?
That will be better, sir. Yeah.
Can you say, when you talk about this remote sensing, why the color of ocean is blue? Anybody can ask, say answer? Okay, then I will ask, can you say some organization in India operating this, where you will get a satellite data in India, from India, where you can purchase this data? Can you say somebody, some institution, or otherwise you can say some institution in India, they are doing research, or they are providing data, or something else like that, training or a calibration of our sensor, or a manufacturing of sensor. So you are familiar with some of the organization in India related to space. Can you say some of the institute?
Sir, there are some answers from our participants in chat box, sir, from Meena Singh.
Because I cannot see that. Because I cannot see this box, chat box, because already it is in presentation mode.
Okay.
Yeah, they can say the answer. It is good. Yeah, I know ISRO. Yeah,
IAS
and also
Dehradun.
you have to keep it. Yeah, Indian Institute of Dehradun is a training center, and also they are doing a lot of outreach program. If you go to the website, you will get a lot of information about Indian Institute of Remote Sensing. The NRSC is a National Remote Sensing Center where you can purchase the data because some of the data is very restricted. Even in the my slide, it is shown as a aerial remote sensing. But aerial remote sensing, you cannot purchase data directly because you need a clearance from MOD, that's the Ministry of Defense. You cannot purchase some data, it is a restricted data. So ISRO is the main agency. Under that, you heard about Department of Space. Is the main umbrella. You will get an ISRO, PRL, Space Application Center, National Remote Sensing Center, like that. So start with that aerial remote sensing. So why I am still people are looking on aerial remote sensing because when you see the data, it is you are getting a high resolution because if you again I am emphasizing on based on your requirement, based on your project, you have to select a data. That is always difficult. What type of data you need? Suppose if you want to get an X, Y, Z, this aerial photograph will provide you X, Y, Z data. You having a latitude, longitude, altitude, and height information. That means you are getting a lot of information about the terrain. Can you put your microphone on mute? Somebody's microphone is on. Can you please mute? Okay. So the aerial photographs are still demand because of the resolution. Because suppose if you see the right bottom side, you can see an aerial photo. In that aerial photo, even I can measure what's the height of a fence, natural fence. Use aerial photo, whether it is a meter, whether it is a 2 meter from aerial photos. But the aerial photos are still demand because of its accuracy, the X, Y, Z data, and also stereoscopic vision of the terrain. So the aerial remote sensing data is again depending on your town planning. If you are go for a town planning or you are going for a high resolution study, you have to depending upon aerial remote sensing. So when we talk about satellite remote sensing, I already discussed there's a more than satellites are on it. Suppose you are a scientist doing the research in ocean, you can take a satellite in the ocean part. Suppose if you want to study in the land, there is a lot of satellite covering on land also. Suppose if you want to study LST, LST is nothing but land surface temperature. So you will get a lot of information from this one. Suppose if you want to study the ocean, suppose the chlorophyll concentration, primary productivity, algal bloom, like that. So you have to concentrate on the ocean like that. So we having a more than 1044 working satellite, but this statistics what I am saying is some 2 years back, I got it from some meeting like that. So there's a lot of Indian and foreign satellite are operating to the study different characteristics of the terrain. So we'll discuss about the Indian satellite, then we'll go for the another satellite. So we having a lot of satellite, some satellite we are using for communication satellite, some are remote sensing satellite, some are experimental satellite, like that. So each satellite having its own application. So when you talk about India, India having a lot of satellite in the orbit. The first we are putting as an IRS series. IRS means Indian Remote Sensing Satellite. INSAT means Indian National Satellite. INSAT is a communication satellite, and all IRS series is a polar orbiting sun synchronous satellite. It's a polar satellite, and it is on the polar region, and it is synchronized with the sun, and you will get a picture only in daytime because it is a sun synchronous like that. So when you take about IRS 1A and 1B, the configurations are same. If you go to the payload, You can see list 3 is the camera, name of camera, linear imaging, self-scanning sensor. It is having a 72.5 meter resolution. And if you take a list 2 camera, it's a 36.5 meter resolution. So you can see the picture on the other side also on list 1 and list 3. The something happened to 1A because the version of 1A and 1B are same. Because something happened to 1A, the 1B will be takeover. Like that, we launched all the satellite. Again, we having a satellite called IRS-1C and 1D. It is having a list 3. It is a 23 meter resolution. The south is, I will show you what is a south like that. VNR is a very near infrared. SWR is a shortwave infrared. Wide field sensor is the ribs, and the panchromatic, it's a black and white camera is there. So each camera having an application like that. So again, India is launched a satellite. It is called IRS. It is also known as OceanSat later period. It is having usually used for the oceanic studies, for the ocean observation, like a SST, ocean color monitor. There's a OCM. There's a sensor is there, especially to study the chlorophyll, because the primary productivity is again to your fishing. That's a potential fishing zone. Like the ocean having a lot of application like that. So concentrate on resource at what? Because India having a lot of satellite in the initial stage, like a 1A, 1B, 1C that. Later they change the name as OceanSat, ResourceSat, Cartosat like that. OceanSat means to the study the ocean. The ResourceSat means to study the resources. And then Cartosat means use a cadastral mapping like that. So when you see the image of P6, the list, it is having a list 3, list 4 and AWIPS. When you see this one image, when I written a lot of things there, the south is a total area covered by a sensor at a time. When you see it's, you can see a white line. Can you say what is the white line indicate? Somebody can say what is this white line? When you see the, can you see the slide? Hello.
Yes, sir. Yes, sir. Yes, sir.
Yeah, any participants, you can say what is that white color that's in a meandering stage like that. That's a zigzag. Can you say somebody? It's a road or a river?
River.
How you can say river? So it may be road also, right? There is a two answer maybe will come. One is a road or it is a water body. When you see the second image in list 3, you can see some blue color is there. That blue color is represent the water, and when you get that blue color, you can easily interpret that this is a river system, but the lean period, maybe it is in April and May. When you take in all the area, the season will be then before monsoon like that. It is in a dry period. That is why you are getting some blue color within the white line. That means if there is no blue is there, you are easily interpret it as a road like that. When you go to list for data, you are getting a lot of patches. You can see lot of red color and lot of gray levels also. What it indicates? What is this feature? Can you say, somebody can say the feature? List for.
Red color is, I think red color is the vegetation.
Yeah, right. It is right. But what type of feature it is that?
የኮሮና ቫይረስ ወረርሽኝ መከላከያ መንገዶችን ሳይዘናጉ በሚገባ በመተግበር
What type of feature it is?
Hello.
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 Abit, hello.
It is actually, it is a cultivation because based on when you go for the interpretation of data,
Sorry, sir.
you it is a paddy cultivation only. Paddy. When you
Okay, thank you, sir. Okay, thank you.
those red patches are there, indicates it is a paddy is already there. The another one is a harvested or it is a fallow land. Suppose it is filled with water, the tone will be different. Suppose when you go for a satellite interpretation technique, we are taking lot of things into consideration. What is the size of object? What is the shape of object? What is the tone? What is the color of object? What is the size of all the things we have to take into consideration like that. When you take a list for resolution is 5.8 meter resolution. Suppose the user have to decide you need a what type of data, whether you need a coarse resolution data, medium or high resolution data. That is why we discuss about the spatial resolution. When we are talk about a spatial resolution. Again, that is depending upon your type of. Suppose you want to study what are the changes in the agriculture pattern in your area, so you can go for a list for data on a different series, how many it is harvested or how many it is fallow lands like that. So this type of data will give you a lot of information like that. And also if you go to SWR, there's a one band is there having a 23 meter resolution in list 3. It is actually for wetland mapping. Wetland is whether it is a coastal wetland or inland. This infrared is basically used for to discriminate and water. So whatever the energy is coming, it is get absorbed by the this water. So you are getting a black tone like that. So there's a lot of application for each bands like that. Here it is a why color of vegetation is a red. Can you say somebody can answer why color of vegetation is?
Sorry, sir, repeat your question.
Why color of vegetation is red in this image, satellite image? The other participants can hear this. Other participants can answer this one. Why the vegetation is, what is the color of vegetation? Somebody? So basically,
I think
because vegetation highly reflects infrared.
Yeah, right, madam. Why? What is the original color of vegetation?
Green.
Why it is green? Why it is green means it reflects.
Because of photosynthesis process.
Yeah, if you say biologically,
because
Our eyes can see that green color.
yeah, sure.
No, the color of vegetation using when infrared has been used should be red color.
I say, okay, we'll continue. Basically, of vegetation getting in Google image, it is a true color, right? What we are doing in satellite data, we are using a false color composite, FCC, what we are calling FCC. So what basically the leaf is green, biologically speaking, it is a presence of chlorophyll, suppose, right? And also another thing is it reflects the green energy is more compared to another. The same, suppose it is having a chlorophyll, you are keeping in a dark room, again it is a black, you need some light, the reflection of light also. And you are getting in color. In the case of remote sensing, when you see the spectrum, the basic spectra, I think you explained morning, the infrared having a more reflection part compared to the blue, green and red. So the infrared is again used to identify different species of plant because each species of plant will having a different reflection pattern. That is why the infrared is used as a first bands. That is why we are calling as a standard false color composite. In basic satellite data, wherever you are getting a red color, That is a vegetation. You can suppose you are getting a satellite data, you can basically classify into two easily. Suppose you are getting a red color, it is a vegetation. There's another is a non-vegetation. That means it is a fallow lands, or it is a building, or it is a road network, like that. Like that, you can slowly do an interpretation in the satellite data. So that is about resource set 1. So again, there's a data called Cartostat 1. The Cartostat is having, actually see the bottom part, even it is an Indian satellite, even you can identify, there is a lot, even the flight, or you can identify in the bottom part, like that. So it is having a 2.5 meter resolution. It is having a mission. That means the stereoscopic, you will get an X, Y, and Z. So whatever we discuss in the resource and ocean sat, the resource sat, you can say only what are the hectares of paddy. But in the resource sat, you cannot say in which altitude that type of paddy is located. But in the Cartostat data will give you your Z value, means in which altitude you are getting a paddy, because you know the paddy will be in the coldlands near to ocean, and also in the highlands, and also in the coastal area, like that. So suppose if you want to study different type of paddy in different elevation, you need elevation data. So that time you can, depending on the Cartostat 1, it is having a 2.5 meter resolution data, like that. So this is a ocean sat. The ocean sat is, suppose you are an ocean scientist, you can do a lot of application in the ocean side. It is having a lot of scanning scatterometer, scatterometer. It will give you lot of information about the ocean color. Usually this is actually related to your potential fishing zone. So, you know, if you go to the website of NRSC and also Bowen, and also INCOIS, Indian National Ocean Information System, you will get a lot of information about the data, like that, what type of waves, tides, current, like that. So we'll see the next one is a research. Research is actually radar satellites. You may be heard about the flood in Kerala 2018, 2017 and 2019. But 2017 and 18, we are not having any satellite in the orbit of radar. Why we launch a research? Suppose during the flood time, you can see on bottom I have written the cropping season in North India starts with the onset of monsoon, and it runs along till October, because wherever rainfall is there, you will not get a data from resource sat, ocean sat, like that. You need a radar. That's a microwave part of the spectrum that is operating between 1 millimeter to 1 meter data. So what for radar, the microwave has a capacity, it will not scatter because its wavelength is very high, and also it can operate any time. It is in the day or night, and it will not affect by a small rainfall. Suppose there's a flood is there, flood is usually associated with the rainfall. Suppose if you're having a radar data only, you can exactly find out how much area is flooded in our country, like that. So the optical remote sensing will not work during the time of cloud, also for a rain. So it's India having recently launched RISAT 2B R1 and also RISAT 2B also. So India having a satellite operating in the radar part, and it is in the optical part. Again, I have to remember that, again, if you are studying a flood or anything related to rainfall, like that, you have to take a microwave data. So this data is, again, basically what it measures is a backscatter, because the one we are using the optical remote sensing, the data is based on the reflection of light that we are calling as a pixel value. Suppose you are getting a satellite, the satellite is divided into number of pixels, each pixel having a value called a digital number. That's based on the reflection of energy. If energy is more, you will having a more pixel value. If energy is less, you having a less pixel value. Again, it is depending upon your atmospheric condition, all the things. But in the case of radar, here we are talking about backscatter coefficient. In the case of optical remote sensing, we are talking about the radiance or the reflection of energy like that. So there's a basic difference between microwave and also in the case of optical remote sensing. So this is the data what we are getting from this cartostat is kept somewhere. So now we are talking about the temperature, sea surface temperature, because nowadays people are very much worried about the climate change. And so we have to know about the sea surface temperature or land surface temperature. There is a two factor is there, SST and LST. So you having a lot of satellite in the orbit, whether it is a NOVA series, AVHHR means Advanced Very High Resolution Radiometer, or MODIS. MODIS also we'll discuss later. Suppose you having a data, so you can discuss, you can generate a lot of data about the temperature. And also you have to see one more thing. The data, the thermal remote sensing is basically for this type of study, because anything related to temperature, sea surface temperature, land surface temperature, the forest fire, thermal effluent, rock emissivity, volcano, like that. So anything related to temperature, because your project is related to temperature, you have to take only thermal remote sensing data. You will not go for the optical remote sensing or radar. For simple example, suppose a forest fire is happened. So the first thing, if you take an optical remote sensing, so your data is full of, you will not get any information. It is full of cloud like that. It is full of smoke. Suppose if you take a thermal data, you can exactly pinpoint from where which fire is started. That's the beauty of thermal data. If anything related to temperature, you have to depend upon on the thermal remote sensing. So I already discussed optical remote sensing. It is basically based on the reflection of energy. Then in the case of microwave remote sensing, it is based on the backscatter coefficient. And thermal remote sensing is basically what you are doing is a thermal inertia. What's the temperature like that? There's a lot of studies are going. There's a lot of satellites you can download free from the internet. Like India is not having any thermal satellite in the orbit for a commercial like that. So what we are using usually Landsat 8 having an oil is there. Some 10th band is the thermal band. It is operating between 10 to 14 million. And Sentinel-3 is a European satellite. That's a Copenhagen. If you go to the website Copenhagen, you can download, sorry, not Copenhagen, Copernicus. You can download the data like that. Suppose if you want to study any big cities or urban cities, you may be aware about urban heat island like that. That type of study, you can see what are the decadal changes for temperature. You will get a lot of information from the satellite, because all this satellite is free of cost. The Landsat 30-meter resolution and Sentinel also, you having a better resolution, it will give you a lot of information about the temperature parameter. So you can study your city also, what are the changes for last 10 years. You can study before COVID or after COVID, what are the changes, because of most of the factories are shut down, because of the thermal effluent may be less. You can study from a thermal data like that, whether the effluent is less or like that before COVID or after COVID. So thing is that the selection of data from a remote sensing means again depending upon your type of project. That is why I discuss about whether it is a thermal like that. Then I will come to this one is microwave. We already described that one. The RISAT is the Indian satellite. In that, what they are using, having a two, one is a active and another is a passive. I will not go for this microwave. You having a good lecture on coming weeks about the microwave remote sensing. So things you have to keep it in mind. The microwave having a lot of application in the remote sensing. Nowadays, people are slowly shifting from the optical remote sensing to microwave and hyperspectral remote sensing data like that. So the microwave, the beauty of microwave is that you can use both day and night because the wavelength is a 1 millimeter to 1 meter. It is having a broad wavelength. It will not affected by your Rayleigh scattering, Mie scattering, or non-selective because the size of particles are less than the wavelength. So it will not be scattered off. So it is having a lot of application of microwave data. Then the new branch of remote sensing is called hyperspectral remote sensing. Hyperspectral remote sensing is actually one of the emerged. Now, I am not saying emerging, it's an emerged field like that people are using, like HISI cubes. Now we are talking about cubes. What we are getting in resource sat and ocean sat, you are getting a discrete bands. Maybe it is a 0.3 to 0.4, 0.4 to 0.5 like that. Here you are getting a continuous spectra of the energy like that. This is an Indian satellite HISI. It is a part of India is also launched recently. HISI is hyperspectral imaging satellite. There's a lot of application of this satellite in the wide range of application in agriculture, forestry, geology, environmental, coastal zone, and inland waters. And even the rock identification. And also, if you go to the civil engineering, there's a lot of application of type of material for your paving on your building and what type of reflection pattern. There's a lot of studies are going on the multispectral bands like that. So there is a lot of application is there, and these are it is a 60 continuous spectral bands on the visible and near infrared. And if you go to the shortwave infrared, it is having a 256 bands. So the essay is having a two payloads, it is written, and based on your study, you have to select what type of spectrum, whether you want to get a VNIR, that's a visible near infrared, or shortwave infrared like that. The data selection is again depending upon the user, and also the resolution. Spatial resolution means it's the size of a pixel, it is written as a 30 meters like that. The SOT is a total area covered by one. And this is one of the handheld spectroradiometer. What we have purchased for our project, it is some cost around some 52 lakhs. What the satellite is doing, we can also do the same thing in the field also. Here it is actually made, it is an ASD company, it is in US. It is operating between 350 nanometer to 2500 nanometer. Same as satellite. Here what we are doing in the field only, just like a equipment like that. So this what we are getting a spectrum. This is an instrument. It is just a backpack. Suppose we are studying how different type of paddies in Kerala behaves, even in the different stage, having a growth. It is most of the paddy having an 80 to 120 days for a full like that. So we had studied in different stages of paddy and different varieties of paddies using a spectroradiometer. Then we have to compare with your satellite data. And these are the different 80 different varieties of paddies. You can see in the infrared part of the spectrum, you can see there's a lot of changes in the spectra of paddy. But when you see blue, green, and red, you cannot differentiate a paddy. But when you go for a infrared part of the spectrum, each paddy having a same time, you can differentiate like that. It is a 18 varieties are there. So that is why I told infrared band is used as a to discriminate different type of vegetation. So the infrared as that is why you are calling as a false color composite like that. And these are some experiment we have done when the weightation. We are doing some stress on the weightation. We are adding NPK in different quantity, the salt water stress like that. Then we are taken reading and to see how the peaks are changes. What we are getting in satellite also, the same thing what we had seen in the morning class like that. That's about the hyperspectral remote sensing. I had given some more about the hyperspectral because it is one of the emerging science in this one. And nowadays, people are talking about the Google Maps, Google Engine, Google Pro, Earth Pro like that, and Wikimapia, Wiki Pro like that. And the Google Maps are the one of the best open source data. You can go for any type of analysis like that. Usually, daily people are using Google Maps in one way or another. Nowadays, your Uber Eats, your Swiggy, all the things they are depending upon your GPS, map tracker, all the things. Again, it is basically derived data of satellite. If you go to satellite terrain like that. So the Google Map having a lot of application like that. I will explain the next slide also. I will link with the Google Map. So Google Maps, we have come to a GPS also. So GPS, you are heard about GPS also. What you are getting data from GPS is also data. So you having an X, Y, and you are getting some information about the location like that. So GPS is usually belongs to US. The same way, the Russia having satellite called GLONASS, the Europe having Galileo, Beirut, India having a system called Gaggle. That's a GPS. That is actually the GPS system we are calling NAVIC, but that program you are calling as a Gaggle. It's a geo-augmented navigation satellite system. The GPS satellite is purely belongs to US. It is an accuracy of plus or minus 3 meters for your location. Maybe it will depending upon your terrain, it will different. So the Gaggle, our NAVIC program, we launched a 7 satellite. My memory is correct. The 4 is geostationary and 3 is a polar satellite. And now all our flight is linked with this one. The flight information system will be under the Gaggle series. So India is now our own navigation or GPS system. The GPS is actually having a US platform. Now India having our own program called Gaggle, right? Now the technology is advanced. Suppose technology is called, we are slowly shifting to LiDAR because of the LiDAR is a light detection. That we having a lot of data, you will get an XY is that it is actually in the cloud format. The frequencies, what they are using is a UV, visible and near infrared in a different phase values. And we are measuring the backscatter from this one. And we are getting a shallow bathymetry as well as for the topographic analysis of LiDAR. LiDAR, but you need a permission from the government, any UAVs or an aerial like that. That is why still LiDAR is having a not, we are using India, but most of the foreign countries like Middle East, US and Australia, they are using a lot of LiDAR work. Basically, the data is in the form of a cloud like that. So this is the data what we are from our campus. We our portico, our this one. This once you having a data, you can find out what is the height of this one, what is the angle of this one. Once you having a data, you can measure all the information about this data like that. So it is actually form of cloud data like that. So that's a LiDAR having there's a terrestrial LiDAR. The aerial LiDARs are there for aerial from the government like that. Now people are slowly come to UAV. UAV is nothing but unmanned aerial vehicles. So if you want to study anything in a disaster, usually a disaster is happen because we cannot go ahead like that. Usually in a case of landslide or flood, you have to depend upon some drones. Drone is a part of UAV, like the drone may be up to, there's a lot of different type of this one. This is one of the drone image of campus. And you can see on the back side, it is the Indian Institute of Management, IIM Calicut. You can see on the back side. So this is a drone image. Once you having a drone image, you can easily identify all the data. You having an all the information you can extract from the drone image. And this is one of the landslide is happened in 2018. You can see on the bottom that there is a red marking is there. Some 10 people lost their life because of this landslide. The origin is somewhere here from morning 3 o'clock. Everything has happened within the some 3 or 4 seconds, minutes. Everything is washed off like that. Again, it's a picture from the drone like that. So drone having a lot of application, especially in industries happen. So the drone having a, nowadays we are using for any disaster is happen, post and ongoing, we are using a drone by the government of Kerala. Also they are doing lot of taking pictures. So that is about, but when you talk about that, again, that is a data only, whether it is a form of video or it is a form of photographs, again, it is a data. So again, the data is depending upon your type of works. So that is all about that data, but we have to discuss some more about high resolution data also, because I already discussed the data can be basically classified into coarse, medium, and a high, or like that. Coarse means it is having, you need a less resolution. Suppose you want to study a land use change, you don't want to a high resolution data. These are iconos data what you are getting in your Google Earth or Google Earth or Wikipedia. You are getting iconos and QuickBed. These and some other satellite now WellView 3 is also available in the case of Google. So this is a web center. It is having a resolution of a 1 meter for iconos. This is an image for a web center before and after like that. Now we are launched a lot of satellite by foreigners like a digital globe. They having a lot of satellite called QuickBed, WellView 1, 2, 3 like that. It is having a 65 centimeter, 50 46 6 centimeter short width means total area covered by a sensor. Revisit means every 2.4 days you are getting a same image. Suppose it is taken from a Tamil Nadu of a particular area, Tirunelveli, every 2.4 days you will get the data like that. The spectral bands, it is have a panchromatic and a multispectral bands are there. So it is a image. It is a, you can appreciate this one. Nowadays, the cargo monitoring can be easily from satellite because you are having a better resolution. From satellite, you can monitor how many cargo is shifted from the base station to your ship like that. So this is a stadium in this one. So the if you go for a high resolution satellite, you have to keep it two things in mind. If the resolution is high, you need a big data platform or data storing platform like a workstation or something else. And also if your resolution is high means again your type of study. Suppose if you want to go for a town planning, you need this type of data. Or if you want to do some sewage or you want to study some city development, smart cities, now a lot of project of government of India like smart cities, that time you need a high resolution data for any type of analysis. So the resolution is also very important to select what type of data is available for this one. So when you talk resolution, it will start with the NOAA. NOAA is a National Oceanographic Atmospheric Administration. The satellite name is AVHR, the sensor. Advanced very high resolution radiometer. It is having a spatial resolution of 1.1 kilometer. When we take a width of Indian satellite 188 meter, then we go to list 3, it is a 23.5 meter. The pan iconos is having a 1 meter resolution. Then Cartostat is also having a 2 is having a 1 meter resolution. Then QuickBed having a 65 centimeter resolution. The WellView having a 35 centimeter resolution like that. That means when the technology is advancing, you are getting a better resolution, the better spatial, spectral, radiometric, and temporal. That is why the first slide I explained, there are different type of resolution we having. One is a spatial, spectral, and temporal. If you look on the AVHR to the WellView 2, nowadays there is a lot of studies are going on about the sensor calibration. There is a high resolution data, the hyperspectral data like that. So these are about the spatial resolution like that. So we'll And there's another part of this is the last slide of this one, not for this lecture. There's another part of GIS part is called virtual GIS. Suppose I am not covering all the GIS, and it is you having a terrain data. Nowadays, there's a Cartostar data you can download free of cost. The the ALOS Pulsar is free of cost. SRTM, Shuttle Radar Topographic Machine is free of cost. You can download data directly. Then you can do a lot of analysis. Like suppose you get a terrain data in the GIS platform, you can build a dam. You can assign a height of dam. You can infill the water. You can calculate the surface area and volume, which time it can be overflow like that. So there's a virtual GIS. You can do it. What you are doing in the AutoCAD, what your 3D AutoCAD, what you are doing in the tunnel. Cut and fill like that. The same thing also, there's a 3D GIS, virtual GIS is like that. Our primary things for any type of this one is the data. That is why the first slide itself I mentioned the data should be in a paper format, or it is in the Excel sheet, or from your mobile photo, or from a satellite, or your GPS X and Y. All these are a data. So all the data you are inputting a common platform, your common mapping platform, you are calling as a GIS. So before then, I thought of, based on the response of the participants, I will go further based on your response of this one. So we'll go for a discussion some part, then we'll start like that. Jidin? Jidin? Hello?
Hello, sir.
Jidin,
yes,
can you hear?
Hello, sir.
So you are the some participants, they can ask some question, then we can go for a further like that. Shall I stop the sharing?
Okay, sir. Okay, sir. Okay, sir.
Yeah.
Dear participants, if you have questions, you can write now. Dear participants, you can raise your queries now.
Somebody is asking about hyperspectral. Yeah, Girish. There's one Girish. Somebody is asking about query on the chat box about hyperspectral data. The hyperspectral data is nothing but when you compare to multispectral, it is a discrete data. You will not get a continuous data. In multispectral, you will get a continuous data on the visible part, infrared part, or that is from a 300 to 2005. That is again depending upon your sensor. But what happened to multispectral, you are getting a discrete value. That is about blue as a one value, green, and like that. It's a bands only. But here it is a cube like that. It is what we are calling as a hyperspectral cube like that. If that is about Sandhu Mandal, if you want to more, I can explain. You will ask. You can just, if you don't want to ask question, you can just type something so I can explain. So there is a Sentinel-2 is available for all Indian region. The Sentinel is available, but it is there's a two parts, is a descending and ascending. The same thing happened. We are looking. It will not complete all the part of India sometimes. That's a missing sometimes. We have seen in the Sentinel. I am not sure about one or two. Actually, we search for the Sentinel data for the time. That repeativity is, I think, about 5 days like that for a Sentinel one like that. But it is covering almost, I think so. I am not sure. I have not searched for entire India because we search for our region only. I am not sure about entire region. About Minasi. Somebody asked about, oh, maybe it is answer like that. I'm not sure. Okay. Okay, there's another question from there's a how can I use a GIS data? GIS data means you have to maybe some other class is when you talk about data, the data means I already told a piece of paper is also data when you write something. But when you convert into a geographically, suppose I am sitting in my home, what is my name? What is my location? My location is a spatial data, my latitude and longitude. What is my name, age, all these things are a non-spatial data. So these are the linking of both the spatial and non-spatial data we are talking about in GIS. What you are doing in Excel, your mic, there's a main difference between the AutoCAD and GIS like that, which is a suitable software for hyperspectra. For if you ask me the question, frankly, I am saying Envy is a very good software, but nowadays others they started with some correction like that. But what I worked in Envy only, Envy there's a if you go for a hyperspectral data, you have to do some correction that you are calling as a flash correction. That means you have to do an atmospheric correction. That is why I am familiar with the NV only, and also you can do all the process in ERDAS also, because what all other data I am expertise in ERDAS, but our hyperspectral project we have done everything in NV also. From which satellite we can find the information about groundwater? There's a good question is there. And also you have to remember one thing. I will answer the question of Jaysri madam. I think Jaysri, this one. Sometimes remote sensing we are using as a direct tool. Sometimes we are using the remote sensing as an indirect tool. For example, if you are having a surface water body or reservoir, you want to find out the surface area of a water body. You can directly find it from satellite data. But for groundwater, based on the expression on the top or topography, we are saying these are the groundwater potential zone like that. We cannot say that if it is a good vegetation is there, there's a chance of water beneath. If it is a dry land, the water is less. That's the one thing. Your topography is main controlling factor. The slope is more, the water will not get having a residence time. Whatever the water is falling as a rainfall, it will directly flow away towards your Arabian Sea or Bay of Bengal. The slope is more important factor for groundwater. So based on the expression, that's a surface expression only, we are saying whether it is a good potential for groundwater like that. But there's a one satellite called GRACE, G-R-A-C-E-E. It is a called, that satellite is called as Tom and Jerry. If you go to search in Google, we are calling as a Tom and Jerry. There's a two satellite are there. There's a base, it will move based on the gravity difference. There is some changes in the satellite, and that you can find out the regional. That means it is a not for a smaller basin like that, the regional changes in the aquifer system. When we talk about groundwater, we are calling as a this one aquifer like that. If you want to study a regional aquifer, we are using this one like that, aquifer. I think she is clear, but sometimes remote sensing we can use as a direct tool and also sometimes as an indirect tool like that. And sir, what type of satellite are recorded carbon dioxide emission of Earth's surface? There's a lot of satellite are there. You can search in internet. It is actually you will get an aerosols data, and also me. There's a lot of data are available. You will get a both, but you sometimes you will get a vertical data because when you talk about the carbon dioxide, you have to see the Earth having a different sphere is there, stratosphere, mesosphere, thermosphere, like that. Suppose sometimes some data will provide the vertical distribution, sometimes the data will give you the horizontal distribution. But I never worked about the carbon dioxide emission of the Earth surface like that. But I am sure that the aerosols data are available. The aerosols are the particles having a 2 mm, more than 2 mm. I am not sure like that. It is available, but there's a lot of satellite are available to study the carbon dioxide emission. It is available. That's I am sure, but I cannot name a satellite, right? And there's another question. Any more questions?
So there is a question from Kumar K. How to use Google Earth Engine to download data?
Yeah, it is. I will explain you because the next part is my about what are the different free data and free data. In that time, I will explain that one. Google Earth Engine is coming slowly. Yeah. And the next session is what are the different type of data, free data and open source. I am skipping in between one thing because there's an application side. Then I will directly go to data. How to download a data like that. That we'll discuss the next session. Shall we go, Jiten?
Yes, sir. Yes, sir. Yeah.
There is another question from Sudha Balakrishna. I have taken coordinates from some object from Google Map attribute data of creation of district, and somehow the coordinate is not accurate. Why it is happening? And you have to keep it in one mind. The scale is very important for any type of analysis because when you take a Google coordinate from a Google Earth on the coastal area, when you go to the office, you will put in your map. Sometimes it is in the ocean. That will happen everywhere because it is a problem of resolution and scale. So when you talk about the high resolution data, you have to be always your the scale should be matched. Then only your coordinate will be come. And also usually in Google Earth, global projection is a WGS 84. And also you have to see one more thing, your GPS having the same coordinate system also. Whether usually when your different persons are using, suppose you are changing any datum or something, you have to be always careful about the datum and projection. That's a one case there. The second thing in the Google, it will always happen like that because of the accuracy of your GPS and also your the scale of your data like that. That will happen like that. So shall I share my system, Jiten?
Okay, sir.
Jiten? Okay, I will
Yes, sir.
do the second. Yeah, tell me.
Proceed, sir. Proceed.
Tell me. Can you see my slides?
Yes, sir. Yes. Yes.
So I am skipping some of the things. Okay. So I will discuss about what are the free data available. I am skipping about some application like that. So I will discuss about free like that. You know, there's a lot of data available in internet. It is a free of course. There's a Wikipedia, Bing Maps, the Google Earth Pro, like that. We are using daily this data for reasons. Sometimes you want to find out what is the distance between that airport to this airport, like that. So, and also there is another thing you are using for your usually traveling. See how much traffic is there, like that also you are using your Google data. And this is one of the app in your mobile. It's one of the very good app. I tried lot of apps in the mobile. You can also download GPS Essential. It's a free software, but in a Apple mobile it will not work. They're having its own application. Usually in any Android you can use this GPS Essential. It's a very accurate method. Other what I had seen, actually I had done some research on GPS Essential some long back. And here you can use waypoints. You can do this your latitude, longitude, like that. When you see on the left side, at least you need a 4 visible satellite. Then only you will get a latitude and longitude. Okay, there's a lot of equations are the root of x minus y1 like that. Why you need a 4 satellite? I am not going to details of GPS part. When you see on the left side, you are in a portable map, Google map, waypoints, like that. While we are using GPS, usually a flood is happen. You want to study what are the area it is affected by the flood. So like that, you can do a lot of exercise in GPS Essential. No need of buying a GPS. Nowadays, there's a lot of apps are available in your mobile. In one of the app is there, Google Essential. This is one of the very good application we had implemented for the flood analysis of entire Kerala. We are done for the 5 districts now using GPS Essential. But there's a changes in the accuracy is there. When you go to the manual, you can improve the accuracy. There's some tests are there. If you go for this one, you will get a lot of information of this one. Once you having a data, it is in the visible part. You will get your latitude and longitude on the top, like that. And this another experiment I had done for our campus. It is our campus and also on the northern part, it is the Indian Institute of Management. On the southern part, it is a Center for Water Resource. My institute was there. So in Google Earth also, there's a lot you can do. There's an option is the historical view. That means what is the changes for your city. That also you can see. When you see the first images is a 2002 image, the second images is a 2011. What you are doing in the change detection studies in remote sensing, the same thing that also you can do in the Google Earth. So what are the new building has coming? What is the new greenery has come? What's a number of vegetation has come? Like that. That type of historical analysis you can do not in the Google Earth Pro. Google Earth you cannot do a measurement of polygon, but in Google Earth Pro you can make a measurement of polygon also. There's an option is there, add polygon. You can add polygon, you can measure like that. There's a lot. Suppose you are not having anything, at least you can go for this type of, these are the free data you will get an available in this one. And also you can add your points, you can find out this one like that. It's about the Google Earth. Nowadays, there's the most effective thing what we are nowadays researchers are doing the Google Earth engine. Google Earth Engine is the most advanced cloud computing base. It is not used for the downloading of satellite data. You can do the processing of your data. Suppose you want to study what is the changes in the vegetation. Usually we are calling as the NDVA something, normalized difference vegetation index, or any type of analysis, change detection like that. That is no need of downloading a data, because what happened, suppose we are doing a project, we want to see what are the changes of my city. I want to download all the data in my computer. My computer became very bulky because of I needed to, it will not have, maybe having a 1 TB data, my system having some 2 TB, then I need for analysis also I need another 500 like that. So now the cloud will be do all the things. It is having an API, it should be in a JavaScript of Python. You having a code is also available in the Google Earth Engine. You can just type like that, you will get this one, so that you can do all the things in the Java. Just to go to Google Earth Engine, then you just type what is your area. If you want a Landsat NDVA, just type Landsat NDVA, it will come. Your map will come, the geometry will come, then you can select a star shape or like that. Then the coding will come. If you want to do an analysis, then you have to know the coding, or you can copy the code Google like that. Getting in a JavaScript or Python. The thing of Google Earth Engine, the beauty of Google Earth Engine is no need of downloading any data. You can do the entire process in Google Earth Engine. Any type of analysis, whether it is a normalized different vegetation index or a drought analysis, in then change detection study, you need a temporal data, means 30 years changes. You can easily do in your Google Cloud. You don't want any space. You just need an internet connection only. You can do a lot of analysis. But one thing, but you have to know some script about the Python. That's the basics of Python like that. If you are very well known the Python, we can change the code also. Then that's the beauty of Google Engine. We can do a lot of analysis. This is a Google Earth Engine. When you go to, you have to sign up. Actually, you have to sign up in the engine. Then sometimes you can sign up through your Gmail account. Then you can take any type of modis data, surface reflection pattern like that. Any type of data you are getting. Actually, somebody is asking whether I can download data. Downloading data, there's a lot of other sites are there. Here, you can play with the thousands of data without downloading. You can do the analysis, get a final map. All the computation will do in the Google Cloud. No need of space. You just need a laptop and a internet. That's the beauty of Google Earth Engine. And my students are in this one, but I am not fully aware about Google Earth Engine. One of my students, she recently have done studies on mangroves. Actually, changes in the mangroves using a Google Earth Engine, using a long-term data. So, if you go to Google Earth Engine, you will get a lot of information about this one. And I will some sites, you will get a data free of cost. One is a ES Earth Observation System. You will get, if you give a start date and end date, it will show you what are the data available at a different levels also, whether it is a Moody's data or any type of data you can get. It is a free of cost, no need of paying any money, this one. But you sometimes you will not get a data, but they will help you. If you are not available, you will send us some proposal, they will give you data in the Nova like that. The LPTAC is one of the good platform. It is actually in combination with the USGS, United States Geological Survey. LPTAC is nothing but it is a land process distributed active archive center. That means you can download all the Landsat or the Moody's data, Astro data, all the information from this site. It's you can just register and you will get all the information, this one. And again, I am not going to discuss USGS. USGS is also having about a lot of data. It is a free of cost. You can download from the internet. Another site is also called Global Land Cover Facility. In that, you can download Aster. The Aster having a 30-meter resolution. It is actually used for the topographical studies, elevation data, The Landsat is available for ETM, MSS, Landsat TM. The mode is having a two satellite called Aqua and Terra. The Aqua is basically used for the ocean studies. Terra is usually for the land. SRTM is shuttle radar topographic mission. What we are getting, I think, is a 30-meter resolution. I think so. It is available. That, but QuickBed overview is not available for the less than 1 meter. It is not available for Indians. And also you will get a lot of derived parameters from the satellites. Somebody is asked about the data that if you go to this one, you can see the Landsat. There's a coastal marsh health index, tree cover, forest cover changes like that. And Moody's also will give a lot of leaf area index like a flood maps, land cover like that. There's a derived product. And AVHR, albedo, band area in Russia, there's a lot of data is available. And the some are you will get a direct data and some are derived data product also you are getting from the satellite like that. And this is another site called Scopus. And here also you will get a beautiful pictures of somebody asked about Sentinel 1, 2 and 3. You can download free of cost. It is having a 5-meter resolution. It is having a radar data, very beautiful radar data and beautiful optical data is available for Copernicus. It is a free of cost, no need of paying any money for this one. And another here what I discussed about Incois, but Incois will not provide data, I think so. But your director, they will share your proposal. They will help you to get a data. But if you go to the website of Incois, Indian National Center for Ocean Information Service, you will get a lot of information like potential fishing zone in the sea, integrated Indian Ocean forecast, like that. You will get a lot of information about the current status of ocean. That is because they put a lot of buoy in the Indian Ocean and Bay of Bengal and Arabian Sea, like that. You will get a lot of information like that. And this another site is called Indian Space Organization, www.nrsa.gov.in, where you are purchasing your data from NRSA. It is in Hyderabad, Balanagar. You will get a lot of. If you go to the website of www.nrsa.gov.in, you will get all the info about Indian satellite, foreign satellite, the EU application like that, Earth observation satellite. If you go to that Buoy, you have to register Buoy, then you can download data free of cost. I think some 6 months back, you can download 6 tiles per day, 6 tiles of data per day. Even you can download Cartostat data. When you go to the open data archives, you will not get a current data, but you will get a past data of Indian remote sensing satellite, SOSAT, ocean, this one, a Cartostat, like that. You can get it. And there's another, if you go to the application sector, water source information system of India, you will get a lot of information of Indian water status. What are the different water table condition? What is the aquifer parameter, transmissivity, like that. There's a lot of information they are inputting in the Buoy. So Buoy, maybe within 2 or 3 years, it is one of the beautiful platform for researchers. You will get a lot of information on this one on the Buoy platform. And the thing is that still also when you go to this one, Buoy also you will get all the information about land use, land cover, geomorphology, lineament, so a lot of information is available. Still, I believe that it is not open for us. This just we can see as a just a web service only. We cannot download any data. Maybe in future, maybe the Buoy will be open for Indian researchers. Now also we want some information. We are keeping this as a web service on the background, and we are tracing about what are the required map for us only. Still the condition is the same for last 5 years. They are not giving for researchers for the data for a geomorphology or a geology or a water. A lot of data is available. When you go to this map, this is actually land use map of Kerala. I can use this, I cannot download this data. it is a 1:50,000 data, 1:25,000, and now they are going for a 1:10,000 mapping is going on. But here I can use as a web service only. When you see this one, there's a web app service like that. There's a two web app service. One is for your open source layer, that's a QGIS, and another for RGIS like that. So I have to copy this one, then I have to select my area. I have to take it as from this Google map. It is just like a web service only. Then your legend will come. Whatever the information is there, I have to extract from there. I cannot download it. That's the main thing is there. And this one I got it from some social media, but I am not familiar with all things. But I am familiar with some data like a freedom 12 meter, that is allows to 10 meter land surface temperature MODIS like that. SAS Planet is a software, I think Corona satellite like that. These are the Landsat images. These are the data are available in the internet like that. These are the sources like that. How to download it's YouTube's are available in the internet to where you have to finalize. I think this one is my last slide. And so nowadays we are slowly shifting to our this one into open source part, and the people are paying a lot of money for the proprietary software. So you can do a lot of things in this one also. The one of the powerful GIS software is QGIS. There's a quantum GIS. You need some 2 MB space or something needed. Then the QGIS you can download. You can do a lot of wonderful research in the GIS. No need of buying any money, any software like that. And also there's a group is there, FOSS 4G, free and open source software for geospatial, then the open source geospatial foundation, and a lot of people are working on the this part, the open source software, and you can also be a part of this one if you know the coding like that. And the thing that is why usually we are shifting from our own platforms like that. So this is my humble request for everything. You can do a free software for any type of analysis. Now Google Engine is one of the most powerful software. Not software, it's a platform. You can do a this processing like that. That's usually what we are calling as a the cloud computing like that. No need of buying any workstation or anything. You having a plenty of data. You can do any type of long calculation. You can download your data like that. So you can ask any number of questions. You have any questions? I will put I will give you my mail ID. If you are interested in any type of research or any information you want, you so I am copying that links in this chat box. Somebody want to copy? You can copy that one. One question by Muhammad Alam: which satellite data is most suitable for chlorophyll concentration? Actually, before we are using OCM, there's an ocean color monitor. Still, also people are using this one for the chlorophyll concentration mapping. Somebody is asking whether we will get a data of the same area of two different years from Google Earth. Google Earth is only in Indian region. They are not updating regularly. That I think you can go for some other, because when you take an Indian region and compare to Australia, our region is updating very slowly. But it is better you can go for a Landsat or a Sentinel data for that type of analysis. But first you have to search in Google. When you there is a tab is there on top portion, view historical image. When you just see this one, you can see what are the different years of data available for your particular area. Somebody is asking about cadastral mapping. Cadastral mapping is actually a high resolution mapping. You know, our cadastral map for our property like that. In olden days, we are calling as a field book. We are using some field books. As a cadastral means it is a high resolution mapping. That is why it is a cartostat. We are saying it is a cadastral level. That means it is in the plot like that. A particular plot of owner like that. They are using like that. Okay.
Excuse me, sir.
Tell me.
So I was using the site DIVAGIS, DIVAGIS to get the shape file, and the shape file of India, it's not acceptable to us as Indians. The shape that they have given for India.
I know, because what I have given, you will not get an entire area of it is not available. Shapefile.
Okay.
What type of shapefile you want?
No, the shapefile for India that I got part of Jammu and Kashmir was not there.
If you want, I will give. You want?
Okay, thank you so much, sir.
Usually, if you go to, usually I will tell you last time what happened when Jammu and Kashmir became two, because the newspaper people, they want to Jammu and Kashmir actually.
Yes.
And you know that is why that time the COVID situation has happened. All the media they having this shapefile of India because of COVID. They want to put their result in the media. It is there. So they approached us like that. They had given that topo sheet like that. We have just made the shapefile of Jammu and Kashmir. If you want, you send them one mail. I will give to you that Jammu and Kashmir file.
Thank you so much, sir.
Yeah, sure. Because one of the media person only had given to me to just trace it. One of my students has traced it and given to him. That is why I told.
Okay. Thank you, sir.
Okay. Okay.
Dear participants, if you have any queries regarding the section, you can raise now.
If you can ask through chat box also, it is good. No need of. Any questions from anybody? Jidin? Jidin? Can I leave? Any questions unless I can leave, right? You can ask once again.
Dear participants, if you have any queries, any doubts, you can raise now. Or you can in chat box also.
You can put in chat box also, no issue. No issue.
Hello, sir.
Tell
Hello,
me,
sir.
tell me. Tell me.
Present time QGIS, which QGIS is going on latest version?
Which one?
QGIS and sir, present time QGIS, which QGIS using in latest version and RGIS also?
I am not. Which you are asking about version? Version?
Yes, version, yes, sir. Both are different.
Yeah,
RGIS developed by ISRI, na?
Yeah.
But which version we using in present time, na?
No, that is again QGIS. I worked up to 3.2 only. That GIS also 10.4. Nowadays, I am not working on any software. That's a great issue. I am not sure about the latest version of this one, about QGIS like that.
Thank you, sir.
Okay. Yeah, somebody is written as 3.14. It is there, right? QGIS. Because when you go to internet, there is a lot of new version, no data, no updation like that is coming. If you go to ESRI, the ArcGIS, when we purchase that time, it is a 10.2. Next year, it is again changed like that. So the basic thing are where you are using QGIS 2 or 3 like that, things are clear. There's an add-on tools. There's a new tools are coming, add-on tools only. But the basic things, what we are studied in GIS is the same for all the version. But you are adding new tools or like that only. QGIS also.
Sir, means every year updated, no?
Yeah, which one?
Sir, every year updated, every year, no? QGIS and RGIS na updated.
RGS, we have to pay the money. That's the issue. If you updated, that is usually people will go for a pirated one. Usually, they are happy with that one. I cannot say like that. If now this year nobody will buy because of the COVID or the issue like that. But nobody will buy any software or anything because the students are using usually in a pirated version like that. And people are happy with the pirated, but sometimes the pirated also make issue in the government organization. That's the issue.
Okay, sir.
Actually, we'll usually buy a good one like that software.
Okay, sir.
Sir, another question from Indrajit Roy Chowdhury. Which software help deep learning method in segregating type of vegetation and making healthy vegetation index?
Yeah, well, I will tell you. I am not sure about software. All the software is good. I am saying that is depending upon the person how you are using NV, DAS, deep learning. There is a forest. Something is there. Machine learning like that. The basic thing, what it is, a segregating type of vegetation from a satellite data. You can use it. There is a lot of hundreds of index are available. In that, there's a main is the NDVA, normalized vegetation index. Vegetation index is there, enhanced vegetation index is there, generalized vegetation index is there. There's a lot of plenty of indexes available, but the thing of the selection of index is depending upon your what type of project like that, right? The index, if I am talking about generalized vegetation index, that is particularly for a drylands, not for the Indian tropical condition like that. That is about the vegetation index like that. That he has to keep it in mind. What type of index is going to use. The software, you can use any software. The RDAS will give you a result. The NB will give you a result. There's a lot of softwares are available. Now it is a Google platform. What I discuss is that it will give you directly NDVA values. If you are going for a NDVA values, the NDVA he can correlate whether the NDVA is nothing but what is the status of health vegetation, whether the vegetation is healthy or not based on its value between the plus or minus one value like that. So he can use any type of. The thing is that he has to know the science. Anybody those who are using the remote sensing, the science behind it. That's the only things that he had to. The index is based on the user only. What type of index? I simply saying I told GVA. GVA you cannot use the tropical condition. You can use in the dryland like that. Like that it is something difference is there. I think Indrajit is satisfied or he can raise some. Is okay. NDVA is one of the good index to study the status of healthy vegetation. Somebody is asked to calculate the landscape metrics using GIS. I am not, landscape metrics means I am not able to carry what is a metrics, landscape metrics, whether it is a land use pattern or the topography or something like that. If you can add something, I can add like that. Both I am not familiar with this patch index, Shanu's entropy index. I am not familiar with that type of index. When you see this one, and frankly speaking, I am not worked on that type of index because we worked on a usually vegetation index like that. He is asking about ecological parameter because basic what we are studying anything on the ecology or a forestry or a watershed or agriculture. The thing is that what you are looking for. That's the main question. Suppose you are looking for a particular vegetation, you are having a lot of data is there. Suppose you are looking on a heat, there's a lot of thermal data is there. The thing is that it's where you are looking for what. That's the main question. That's based on that type, your index will be different, your equations will be different, and also satellite. Based on the satellite, also your NDV equation will be different. That's the infrared minus red divided by infrared plus red. Sometimes it's a short wave minus red like that. As again, depending upon the satellite, also your equations will be different like that. The basic things will be right, but your band will be different like that. So there is a lot of data is available for ethane. Maybe it's methane, ethane, aerosols, methane like that. It is available. Sure, I had to look on the Google like that because a lot of nowadays people are discussing about climate change. Maybe this type of data is available not in the resolution of what I told. It is 30 meter. Maybe it is a 1 degree by 1 degree or half degree by half degree. The main issue of climate data is there. It is not based on our resource data like a 30 centimeter or a 30 meter resolution. It's a data is usually like a 1 degree by 1 degree or half degree by half degree or 25 kilometer by 24 by kilometer like that.
Participants, you have any other queries? Okay. Sir, there is another question from Arjun Shah regarding village level shapefile data.
What's the 2014? Oh, okay. Arjun Saha, it is written as a. So, can you help me to provide a link of village level shapefile data? The village file shapefile data, you have to get it from your concerned disaster management section or your state remote sensing center. You have to get because this village or your this will be changing will be happen for a village boundary like that. That you have to be collected from your concerned department only. That but I think data because the census because of the boundary what you are talking about the boundary of data. If boundary is there, the boundary you will get it from your state disaster department or your custodian like a remote sensing center of your state. The thing is that if it is you can just changes. Usually census data is in the PDF format. It is now available. That village level you can just change the spatial information only. That's an easy way.
Okay, but yeah, more queries. Okay. Then shall we wind up the session? Hello, sir.
Sure. My thanks to your professor and your your institute. Convey my regards to professor also, right? And also your Dr. Chandrasekharan sir also, right?
Okay.
And also for all the participants also. So they are very patient for some 1.5 for 145 minutes. Okay, thanks. Thank you for calling for this lecture. So I can also update some information for the participants. They are asking what is the version of QGIS like that. So I can also update something from the participants also. It's a nice experience, but in Google it is sometimes it is a one-way system like that communication. But anyway, I enjoyed a lot. Even in the chat box, they asked a lot of questions. Right? Okay, thank you.
Okay. I thank you, sir, for giving a valuable session on data available from remote sensing. I think this is a fruitful session for us. I thank all participants for your kind cooperation with us. Thank you all. Thank you. Thanks a lot. The feedback link is available in Google chat room. Thank you all. The feedback link is available in the chat box. Thank you, sir. Thank you so much.
Thank you. See you. Bye. See you.
Okay.